Hello everyone. In this video, you can learn how you can run and simulate an first order and second order active Butterworth high pass filter. So here I have already drawn the circuit diagram. So initially open up your LTspice and then here I will open up my circuit diagram. First order high pass filter. So see here, this is a circuit diagram of an first order high pass filter. Here, why we say first order means, as I have already mentioned in my previous video on first order and second order low pass filter, same thing here. Here we have used only one R and C. That is, here this R is connected to ground, and then here this capacitor is connected to our supply voltage. So that's why you say it's a first order. That is only one RNC. So we say first order. Suppose if we connect another RNC means we will say that it's in second order. Here this is an active filter because this RNC is connected to our operational amplifier. And then here also it is a Butterworth filter. That is we used a Butterworth filter. That is we have taken alpha is equal to 1.414. Why we utilized Butterworth filter means in order to get a flat to flat output response. That is why it will avoid all the ripples. So here we will see the components usage. So here this R2 and then this R1 is used to find out the overall gain of the filter. That is, see here the formula to find the overall gain of the filter is A0 is equal to 1 plus RF by R1. Here I am named as an RF. So here that is a feedback resistance. But here in circuit diagram the name is given differently. So don't confuse on this. So here RF value is 5.86K and then our R1 value is 10K. Just substitute in this formula, then we will get A0 is equal to 1.586 volt. That is maximum overall gain of this filter is 1.586 volt. Now this R and C, this R3 and C1 is used to find out a cutoff frequency. So here we have it designed for an 1 kilohertz cutoff frequency. Suppose if you 1 kilohertz means here FC is equal to 1 by 2 pi into RC. So I have taken the cutoff frequency is 1 kilohertz. Suppose if you want to design it for 2 kilohertz means, so here you have to substitute in FC as 2 kilohertz. That is up to you. That is your choice only. So here I have taken as in 1 kilohertz and then C I have assumed as in 0.01 microfarad, and by substituting in this formula I will get R as in 15.9 kilo ohms. So I am just substituting it over here. R is equal to 15.9 kilo ohms. So here I have taken the cutoff frequency as 1 kilohertz. That means now here since it is a high pass filter, that is it will pass all the frequencies above this 1 kilohertz only, and below this 1 kilohertz it will cut off all the frequencies. That is, it will not pass the frequencies below 1 kilohertz, and it will pass the frequencies above 1 kilohertz. So according to your applications, you can use whether you want low pass filter, high pass filter, or a mid band pass filter. So now, yeah, now we will see this voltage is V1 and V2 is nothing but your supply voltage for our operational amplifier, that is plus VCC and minus VCC. So here this is nothing but your V3 is nothing but a function generator. So how we have to give this function generator means voltage source function generator means I already mentioned. So you have to move your point cursor to the top of this voltage source and right click on this, and then here you have to select sine wave, and then DC offset is 0, amplitude is 1 volt, frequency is 50 hertz, and then here AC amplitude you have to type it written as a capital AC, and then phase is in single phase, and then click OK. Now go to simulate and then click on this edit simulation command, and then here you are going to do for AC analysis, and then type of sweep is decade, number of points per decade is I have taken as a 10, that is also your choice. Your start frequency I have 100 kHz to 5 stop frequencies 5 kilohertz is also your choice. You can give from 10 hertz itself, you can also start, that is also your choice. So I'm just clicking here to OK. Now when you have before running the program, you have to save your program and then you have to run your program. So now we need to see your output. So a red color is your voltage. So just at the output side, click this one. So see here, we have got our first order high pass Butterworth low Butterworth filter, high pass Butterworth filter. Now so see here. So when you move your cursor here, this cursor will come, just move this one. So see here, this is an first order. So we will see practically what is our cutoff frequency. For that, we need to move your cursor at the maximum gain. What is the maximum gain we are getting? 3 point maximum gain we are getting as 3.8. So if you minus 3.8, so if you minus this minus 3 dB, that is maximum gain minus 3 dB. What is that? 0.8. That is 3.8 we are getting as a maximum gain. So if you minus that means you will get us in 0.8. So you can see that over here magnitude, the values on the values will be changed. So you can note it from there. So 0.8. So 0.8 is it's 0.8. So what is the frequency you are getting? 970 hertz. That is we have not got as an same cutoff frequency we have not got. That is we have designed cutoff frequency is 1 kilohertz, but you are getting as a 970 hertz. So what we need to do, we need to improve our cutoff frequency. So what we can do, we need to go for second order high pass filter. That is we need to add one more RNC. So then we will get exactly our same cutoff frequency. So see here, we are getting only at 970 itself. It started to pass all the high frequencies. So see here. So now we can note down the readings. That is frequency versus what is your now gain in terms of an dB. That is if you want to calculate in theoretical means formula is 20 into log base 10 of V naught by V in. Example, now we want in terms of an voltage means we need to move our cursor to the y-axis and then right click on this and then here select linear and then click OK. Yeah, in terms of voltage you can note it down. Now in your tabular column, now you need to, so this is your tabular column. For particular frequency, what is the output voltage you are getting and what is the gain in terms of, and this is by 20 log base 10 of V naught by V in, we can calculate theoretically. If you want practically means from the graph, you can note down the readings. So input voltage is 1 volt. Now, in order to improve our cutoff frequency, we will go for a second order high pass filter. So I already drawn that circuit diagram. So I will just open that one. Second order high pass filter. Yeah, see here, same circuit diagram only, but see here, till here you will get your first order high pass filter. By adding one more RNC, you will get your second order high pass filter. See here, this capacitor C2 and R4 is and again added. So here also the C2 and R4 is used to find out your cutoff frequency. By selecting your cutoff frequency, so here I have taken as 1 kilohertz only. Suppose if you want 2 kilohertz means your this R value, this R4 value will change. So according to which you have to you have to we have to rename your resistant value. So here this R4 and C2 will is used to find out your cutoff frequency. Next is R1, R2 is used to find out the overall gain of the filter. Here also same overall gain of a filter is 1.58 volt. So now this V1 and V2 is nothing but your supply voltage for this op-amp, and then this V3 is acted as a function generator. Just go to simulate and then edit simulation command, give this decay 10. So up to you, it's your choice only. So I'm giving this 100 hertz to 5 kilohertz at stop frequency. Okay, save your program and then go to simulate and then run. So I will close this first order high pass filter diagram. So now what output? Yeah, see here. Now we will take the cursor and then move here. What is our maximum gain? Maximum gain we are getting as 3.9. If you substitute minus 3 means minus 0.9, you will get 0.9. Yeah, for 0.9 you're getting frequency as 1.0.9. Yeah. 1.00 kilohertz. So we are getting exactly the same cutoff frequency. So that's why I moved it for second order high pass filter. So this is how you can run and simulate an first order and second order high pass filter in LTspice. Thank you.